Solve question from linked list, from Leetcode list. Today is our linked list day, so let's solve this question from linked list. Remove duplicates from sorted list. So let's do this. Hopefully I have not done this earlier. So, okay, remove duplicates from sorted list. Given the head of a sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. Sorry, I got a little bit lost there. So the question is, given the head of sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. So I believe if there are duplicates, then the size of the linked list should be always 2. So the first element will not be a duplicate, right? So that's what I'm guessing. Let's see the constraints here. The number of nodes in the list is in the range of 0 to 300. So there might be a situation where we have nothing in our list at all. Okay. Okay, so what should we do in that case? Let me adjust my camera. Yeah. So looks like our head can be null. The number of nodes in the list is in the range. Okay. So 0 to 300. So looks like our head can be null. So that is one of the thing. If our head is null and head dot next is null, then we'll simply return head. That would be the base condition. If our head equal to null or head dot next equal to null, then we will simply return the head. Okay, we don't need to do anything else. Yeah, and if that is not the case, then we might have two heads, right? Two heads with us. So what should we do? What should we do in this case? So first thought that comes to my mind is I can have a dummy whose value what? So this is minus 100. The node value can range from minus 100 is less than equal to 100, right? So I can have it have the value as minus 200, yeah, or minus 101, whatever. So yeah, I can have that value as the dummy, and set it as our previous, whatever our previous would be, that will be that, or in fact we don't even need to have a dummy. I can just have a previous which will be equal to null, and let's say I start from my current, and if okay, so if my current will be equal to previous, then that would be a problem. Then what I have to do is my previous dot next should be my currents dot next, right? And we should keep the same current and not update anything, and then keep then check if the currently set current was also similar, because each element, uh, given the head of sorted linked list, delete all duplicates such that each element only appears once. Return the linked list sorted as well. Okay, so sorted linked list is already given to us. So basically, what we can do is, there might be any number of duplicates, right, in it. So yeah, my idea is to, once we find out that it was equal to our previous, then we won't like go to the next element to see. We will stay on the same element and keep checking that unless and until it is different. So yeah, let's do it. Like, but when we reach to the end of the node, what should be the case? That's what I was wondering. But previous is equal to null. Let's do that. And what we'll do is, let current is equal to head. If I do that, and while my current is not equal to null, I want to keep going ahead. Yeah, so if my current is current dot val is equal to prev dot val, or if it is or just prev. Okay, if current dot val is equal to previous element, then what I need to do is, yeah, previous, if prev is not equal to null, and first I'll check this condition, and if it is not equal to null and prev dot val is equal to whatever we have right now, so previous dot next would be current dot next. So we'll skip that value. Okay, and current is equal to current dot next. Okay, yeah, that's what we'll do. So once we do that, we have to come out of the loop, else if previous is not equal to null, else if previous is not equal to null, and current dot val is not equal to yeah, current dot val is not equal to prev dot val, then what I will do is, or I can simply do, if that is the case, I can simply have a else condition, right? Else what I can do is, prev will be equal to current, and current would be equal to current dot next. Yeah, that should be it, right? Instead of, and finally we will return whatever head was there. Okay, yeah, so yeah, that should work, I believe. So see there, this worked, and let's see if, okay, cool, yeah, this worked. So okay, my logic was pretty clear. that will go to the end of the null, and we'll have a previous which will be initially set to null, and we are just checking if our previous if it is not equal to null and our current value is equal to the previous value that we have seen, then we want to set the previous value to the current, and current will still be pointing at the current dot next, so that we don't go ahead, we don't move ahead and skip the duplicate. So that's why we are doing that. Like a better approach would be to show you guys how it would be working. So yeah, let's do that basically, like to get better understanding of what is happening. Should we do that? Should we do that? I guess yeah, we should do it. Okay, let's open up the Miro board. Let's go back and see product roadmap. Okay. Looks like I have reached. Let me delete this board. Delete. Okay, so I have this guy. What I'll do is delete everything. Let's open up a Miro board in here. Miro board. Why is it taking so time? Okay, so we are here. So what the first edge case was, our node could be just null. So if this is given to us, we cannot do anything, so we'll return this guy itself. And the other edge case was, we have been just given one node and the next is null, so at that point also we have to return the head itself. So at both time we are returning head. So that was our edge case. And let's see, so the example that was given there was 1 1 2 and null. Okay, so our previous at this point is, let me write previous is equal to null, and our head is pointing here. So our head is equal to the current one, right? Our head is pointing to 1. So what we do is, let's call it current as we did it in there. Our current is this current. Okay, so what we do is, once we see that previous is null, then we simply update the previous with our current, with whatever current that we saw, current node, I mean, oops, sorry, you guys are not able to see that, right? Yeah, whatever current we saw, we'll keep that in the previous, and then our head would be pointing to the current start, like our, sorry, let me call it current, and then we'll move our current to the next node by doing this. Current is equal to current dot next, right? That's what we did there. Oops. Okay, yeah, that is what we did there. So our current from this point, it will move to this guy, sorry, back, yeah, it will move here, and once it moves here, what what we can do is our previous was let me write it in terms of whatever the value is. So our previous value was pointing at 1, right? It was pointing at 1. So we'll check if our previous is not null, then we can compare the current head's value, current pointer's value, that is 1, and if it is equal to the previous value, then what we want to do is previous has still a reference of this guy, right? This guy's reference it still has. So currents dot next and previous, so currents dot next and previous dot next will connect them. So current dot next was 2 and previous dot next would be connected here, and yeah, so that's how the link between these two guys will be terminated, and this we will lose a reference of this guy. Okay. So yeah, like, and then we'll basically move our current pointer to this new guy, and which is 2, and then we'll again go in the loop and check if our current is equal to the previous, but it is not. Then we set the previous to 2, whatever our 2 is, and we'll update the current to next, which is null, and as soon as we reach null, we will end the in this function. So that's what is happening here. That's what we did here. Okay, so this the time complexity of this would be O of n, and the memory would be, like, space complexity would be O of 1. So yeah, that is what this solution is. Okay, let's see how many companies like to ask this question. So a good number of companies like to ask this question, like for given 1 to 2 years, good companies have asked this. So we'll like this and store it in our linked list questions. Have we done this before anytime? Let's see. Oh no, this was the first time we did it. So yeah, okay. So we are 17 minutes into it. Let's also do another question from the linked list. We'll do a medium question this time. So it's we are always balancing out between what we are doing. Okay, so let's close this out. Let's bring this maximum. Okay. Okay, so we have this maximum twin sum of linked list. Okay, let's do this. In a linked list of size n, where n is even, okay, the ith node 0 indexed, okay, of the linked list is known as the twin of the n minus 1 minus ith. Okay, so minus I node if 0 is less than equal to I and I is less than equal to n by 2 minus 1. Okay, for example, if n is equal to 4, then the node 0 is the twin of node 3 and node 1 is twin of node 2. These are the nodes with twins for n is equal to 4. The twin sum is defined as the sum of a node and its twins given the head of a linked list with even length. Return the maximum twin sum of the linked list. Return the maximum twin sum of a linked list. Now let's see the example here. we have been given a head. Okay, sorry, we have been given the head 5421. Okay, so output would be 6. 0 and the last element will be equal, right? That's what it is. 0 and 1 are 0 and 1 are the twins of nodes 3 and 2 respectively. All have twin sum 6. Okay, 3 and 2. Okay, 0 and 1 are the twins of node 3 and 2. Yeah, got it. 3 and 2. Why is that 3 and 2? Oh, 0 and 1s are twins of 3 and 2. All have twin sum of. Okay, got it, got it. So 4 plus 2 is also 6. 5 plus 1 is also 6. There are no other nodes with twins in linked list, thus the maximum twin sum of linked list is 6. So after looking at the question, I guess what this equation is trying to say is, if you divide, like, as it is going to be even length, right? So if you divide the linked list from center, then you can see a pattern. 5 is the last node, 4 will be the second last node. So it's like that. So what comes to your mind? Like, there is in linked list we cannot traverse a back, right? So the only way of adding these two, 5 to 1, 4 to 2, like my intuitive thought is, we'll use the rabbit tortoise method and like fast and slow counter to reach the midpoint of the linked list, and then once we get the mid, we will reverse the mid, starting from the mid, and so that this 5 4 will stay intact, but this 2 1 would be 1 and 2, and then we can start traversing from the first head and the reversed mid's head and add them and have and keep our maximum linked list count and return it. So that would be it for this one, I believe so. Yep. So reversing. Okay. But yeah, I need to be careful about small inputs. Not much, but okay, let's try this out. Let's try this out. Unless and until we won't try this out, we won't know. Let's time ourselves. Like I've already been. It's been like 17, right? 18 minutes. So 5 minutes have been passed reading this question, understanding what to do. So I have the solution. So what I need to do is I need to have a slow pointer and a fast pointer, which will be pointing to head. This guy will be also pointing to head. And what we have to do is, until fast is not equal to null, and then we have to see fast dot next is not equal to null. I guess fast dot next is it fast dot next, fast, or fast dot next dot fast dot next. Yeah, I believe so. We have to do, or we'll just keep this like this. But the thing is, if there are just one node, can there be just one node in here? Okay, the number of nodes in the list is even integers. 2 so is node values. Okay, so there will be always 2 nodes with us, right? If there are 2 nodes given to me, so my head would be pointing at the first node. So head um, dot next dot next. Yeah, that should be fine. That should be fine. So slow is equal to slow dot next. Slow would be moving in that pace, and fast is equal to fast dot next. Okay, so that would be the fast. Okay, I did not put it perfectly into the curly braces. Let's do that. And then probably what we can do is yeah, what we can do after this is we've got our slow pointer would be our mid, right? So basically reverse slow, we need to send the slow pointer and let slow head is equal to, yeah, this reverse will send us the slow head. And what we have to do, as it is even length, so they both be of equal sizes, so I don't need to worry about what one running out sooner. So let max sum is equal to, so everything is positive number, right? Let's check that. Let's check that again. So node dot val is positive. Okay, so I can have 0 here. Okay, max sum is 0. And then what I'll do is while so my slow head is there, and let current is equal to head. Okay, so I have this as well with me. So while current is not equal to null, will keep going ahead. So we have to just take our max sum equals to, we have to just do mat dot sum, and once we do that, then sum max sum, we have to check if this max sum is greater than the current max that we are looking at. So current dot val plus slow, okay, let's call it current slow dot current slow dot val. Yeah, if that if the calculation is greater, then we'll update it. Otherwise, what we want to do is we want to check for next values, current dot val and current slow dot val. Oh, sorry, not val, next. We want to check the next element, right, for both of them. So current slow is equal to, yep, that's what we have to do. And basically in the end we have to just return max sum. But guess what, no one is going to come here and write the reverse logic for you, so you have to write it by yourself. So let's write the reverse function as well. Function reverse, the head is given to us, and what we have to do is reversing is like iterative is pretty easy. We have to have a previous node which is null, yeah, and while, and let's take let current is equal to head, and while current is not equal to null, then at that point, till that point, we have to keep going ahead. So prev, so we have to actually store let next is equal to current dot next, because we are just going to assign current dot next to previous, whatever the previous value of ours was. Once we assign that, then previous would be the current, and current would be the next. If we keep doing that at the end, then whatever the previous value we have will have our head, like the reversed head, and we can simply return that, right? Okay, so cool. So what we have to do is, once this is everything is done, we have to just go here and run this code. Oh, mat dot not sum max, sorry, my bad. Cannot read property of null. For which one? Is there any particular? So 0 and 1. Okay, so let me see what my head is returning, like my, I guess, so log current slow dot val. So I don't. So let me just check it for this one, if this is working fine. No, that is also not working fine. So my slow head val is 1. Yeah, that is right. That is right. Then what is the problem? Isn't it val? Yeah, it's val. Current slow. Yeah, so current slow, I'm pointing it here. Okay, let's console.log whatever current slow that we have seen. Okay. So whatever current slow that we have seen, current dot slow, current dot val, comma current slow dot val. Let's run this. So I saw 5.1, I saw 4.2. So why is it going again? Like, it should have stopped. Should I just check for and current dot current slow? Oh yeah, oh okay, yeah, okay. So our, I forgot that our 4 would be pointing to still to 1. So I believe I have to do it for current dot slow. Yeah, so now it will work. Sorry about that. I didn't took it into the consideration that yeah, I forgot that link might be still be present. So okay, so we did this and this is passing. Let's submit this. Okay, yeah, this worked. So the time complexity, let's discuss what the time complexity would be to reverse um, the nodes. That would be log, that would be what operation? Like we are just doing the half of it, right? We are reversing just the half of the linked list, but in order to get there we might be traversing it. So I guess the time complexity of this should be n, log n, for this guy reversing it, log n plus plus whatever n plus log n, and so O of n would be the time complexity. Let's see what the editorial says. Yeah, O of n is the time complexity, and space is also O of 1. So how did they do it? While current dot append values dot append current dot val, current is equal to current dot next. Okay, okay, got it. So they used an array basically. And stack is using stack is also the same thing, popping it reverse second half in place. So this would be O of 1, right? Yep, O of 1, O of n and O of 1. Okay, the first two are also nice. Having a stack, reaching to the mid, put everything onto the stack, and then start popping it once you are traversing. Yeah, while the stack is not empty, start popping everything and adding to the first element. Okay, cool. So let's see how many companies have asked this question. Okay, just Amazon likes to ask this question a lot, like 33 times it has asked. So pretty good question, I would say. Okay. Where is my linked list? Add. Okay, I've added this. Cool. That is it for this one, guys. Hopefully that was helpful, and see you in the next Leetcode gem. What do you say? Stream. Yep. Okay, that is it for this one. Bye bye. Take care.